So this is the first of a series of videos I have planned for you, looking at the ZX81 and doing some fault finding. I'm hoping this series will teach you everything that I know and possibly a little bit more as we go along, and give you the skills to have a go yourself and do it with some confidence. I'm going to keep it really basic, simple, straightforward, because that's like me. And I'm going to show you the tools that I use and how to use them. So this first video, let's have a look at the power supply. So the tools you'll need for this video isn't a great deal. You'll need some form of multimeter like this. Doesn't have to be as complicated. Much simpler will be fine, because all we're going to be doing is using it for voltages and continuity on the fuse. A pair of test leads and screwdriver or screwdriver bit set like what I've got here. So here we have the ZX81 Power Supply. This is a UK spec one, fitted with a UK plug and the standard 3.5 audio jack style power supply plug. So depending on the market yours was sold in, it may differ from this, but I'll explain this power supply and what we're going to do to test it to see if it's in working order. So whilst there may be variances with different markets, the Americans with 110 volts, etc., different style plugs, these are the basic steps that you need to go through, and you just need to adapt it accordingly for what's fitted to yours. So before we start messing with the supply itself, we need to have a look at the plug. The UK plug's fitted with a fuse. It's not a big job. It's centre screw and it should open up. There we go. It's really important that you do these checks, because a lot of, in fact most, certainly UK household appliances didn't come with a plug, and as such people would fit them and they weren't necessarily wired properly. So the important things to look for, we notice this one isn't earthed, which isn't a problem for us. We've got the neutral coming in there and we've got the live there, and obviously we've got a 5 amp fuse fitted, which in this instance I would suggest is overkill. But the fuse itself looks rather grubby. But what we'll be checking here is if we've got continuity on the fuse between the two pins. And we'll also be checking as well to make sure that these wires are nice and secure and there's no tails poking out of them, no loose wires. And to be fair, it looks okay. Let's do a quick continuity test on the fuse. So to test the fuse, we just need something like a multimeter like this. Doesn't need to be anything flashy. And we're just going to put it into here, continuity mode. You could test resistance as well, but we're just looking to see that, as the fuse implies, we need to make sure that there's a flow of electricity through it, because if electricity is not passing through the fuse because the fuse is blown, then we're not going to get any power further. And my meter beeps. The oxidation on the fuse isn't great. So I've just popped the fuse out here and given it a bit of a clean. Ideally it probably could do with replacing, but it's going to be fine for now. Any doubt, so just replace it. 3 amp fuse. But as you can see, continuity is good with a bit of a clean. So that's the plug. We'll get it back together. Whoops. So this is the other end of the supply then. This is the 3.5mm jack. What we need to do with this is test to see that the transformer part, which is that, is outputting a voltage, and the label says that we should be anticipating a 9-volt output. Now, to test it, it isn't complicated. You just need something like this, a multimeter, and we'll set it to voltage. Okay, for direct current. You need to read your instructions on measuring voltages, because there's also a setting for measuring voltage for AC, but we want the direct current, which is what this outputs. So think of it just like a battery. It's not like mains power. It's just like 9 volts out of a battery. So to test this, it's not tricky. If you notice the barrel, there's 2 sections separated with a little black bit. Now the little black bit is like an insulator. The end of it, and it's quite safe to touch, is like the positive, and the shoulder up here is the negative. And when you insert this into the socket on the ZX81, the positive and negative connect up accordingly with the socket. To test it is really straightforward. So according to the instructions on the power supply, we're looking for at least 9 volts. So with your 2 test leads, it's just a case of touching the black one. It doesn't matter if you get it the wrong way around, it won't make a difference. It'll just say negative instead of a positive. Touch the black lead on the top half, so that's up here, okay? Just hold it in place. And then just touch the other one onto the end part, past where it's black. If we do that, we can see that it's outputting 13.68 volts. Just take it off and touch it back on again. Yeah, 13.68 volts. Now I said, from the instructions, it outputted 9 volts. So the thought process may be, well, there's a fault with this, but that isn't the case. The ZX81 Power Supply it's unregulated. I'll just zoom out a bit. It's an unregulated supply, which means that, as opposed to things like the power supply for the Amiga, which is regulated, an unregulated supply means it's going to deliver a minimum of 9 volts, but that value that it delivers may vary. And the things that could cause it to vary is the load that's applied to it, so how much power, how much work it's having to do. The more work this has to do as an unregulated power supply, the lower the voltage becomes. So if you think about it, once we connect up the ZX81, with it being unregulated, we should expect that voltage to drop. And without getting too complicated too early on, inside the ZX81, it takes the voltage that's supplied to it, and to drive the components inside it, which need 5 volts, there is a voltage regulator inside the machine, which drops the input voltage, which in this case is showing just under 14 volts, and drops it down to a usable 5 volts inside the machine. Reason why it's unregulated, it's cheaper. That's the only reason I'm aware of as to why they've used an unregulated supply. It makes it cheaper. The downside is all the excess power inside the machine makes it quite hot, but we'll have a look at that in later videos. So I'm quite happy that the connection looks good, it's nice and shiny, and we're getting out a suitable output voltage. You're quite safe with any voltage until it starts getting too high or too low. I think the voltage regulator inside the machine is good to 25 volts. So anywhere in that ballpark, 13, 14, 15, 16 volts, you're going to be absolutely fine. You're going to be absolutely fine. So that's the power supply. We'll move on into the next one at looking at getting the motherboard out of the machine and testing the supply once it's connected up to the machine.